All right, everybody. How is everyone doing? Hopefully, you're all doing great. We are going to be talking about our national parks. So, these were national parks that I had you guys look up some information on some sites the week before we went on spring break. And I want to go into some detail on these, but not as much as I'd love to, because this video would be 3 hours long about each national park and how it's amazing when it fits in with um, geology, the study of the earth, and weathering and erosion, because each one is incredibly special because of those reasons. Excuse me. All right, so here's our national park um, logo right here. And the story about national parks is really interesting. So this starts with our president here, not our current president, of course, but this is Ulysses S. Grant. And he's an amazing person. He was a Civil War general, Civil War hero, eventually becomes president. Born and raised in Ohio, which is really cool. Georgetown, Ohio, which is not far from Amelia, is where he grew up as a boy, went to school there. But Ulysses S. Grant, back in 1872, you can see right here where it mentions the 42nd Congress of the United States. You've talked about Congress, that's our legislative branch of our government. Set aside Yellowstone National Park. I'm going to talk about that in a moment. As our first national park. So back in 1872, people realized that some of these places were so special that we needed to protect them and set them aside as a national park. So what I'm going to do is I'm going to talk about these national parks in terms of distance and um, how far away they are from Amelia. So the closest national park that we're going to be talking about is Mammoth Cave. Mammoth Cave is in Kentucky. Here is a map here. So if we were to start in Amelia right here and drive south into Kentucky, we would be in the car for about 4 hours and 3 minutes right through here. So Mammoth Cave, if you were to go to Mammoth Cave and go through what's called the natural entrance, this is what you would see. This is an entrance that was made by weathering and erosion. This is natural. There's been other entrances made, but those are man-made entrances where we've dug into the cave to get to different parts of it. And what's really interesting about this is we have this equation. Limestone is this type of sedimentary rock that's made by the fossils of little microscopic ocean animals, and we have rainwater mixing with air, and what that makes is that makes carbonic acid. And it sounds intimidating, but really that is the same type of acid that we drink when we drink pop. So I want you to think about the limestone is very similar to our teeth. It's hard, has these little openings in it. If you were to look at our teeth under a microscope, we would see these openings. And the mixture of that material with that type of acid creates openings. And in case if our teeth, if we don't take care of it, it would be cavities, right? So what's really neat is over millions of years, this flow of water in this chemical weathering. So here's this phrase here: chemical and physical weathering. So the chemicals of that water and rainwater and air, and it makes this acid, and the movement of the water has made over 400 miles of cave. Mammoth Cave is the longest cave system in the world. It's not the biggest in terms of opening, but it is the longest, and that's why it's so special to us, and we made it a national park. And they're even finding more parts of Mammoth Cave every year as they explore more and more of that. So Mammoth Cave has a lot of these amazing formations that are caused by the drip of water. And I want you guys to think about the salt block and the crystals that we had forming on the side of our tray. Do you remember seeing that? That is happening the same way these formations are happening. So every time water drips through this cave, it leaves a little bit of stone behind, and eventually that stone builds up and it creates these really neat formations. Mammoth Cave is really famous for a lot of these formations. Mammoth Cave has some really neat history as well. People have always been interested in the cave, and there's a portion of the cave you can go to, and you can see names written on the ceiling. And what happened was, over 100 years ago, tour guides would take people into the cave, and if you paid your tour guide money, they would write your name on the ceiling with the torch that they would use. That, of course, now is illegal in a national park, but it's really neat because now we have a historic record of all these names and dates of people who visited the cave many, many years ago. So, as mentioned about exploring the cave even further, there are people who will go what's called spelunking into the cave and travel through these passageways into these tight, tight places where they have to crawl on their belly into these really small places to discover it. But then also, they'll use what we call that dye tracing. If you remember, we did that with our salt block, where they'll pour in that environmentally friendly dye and just wait for it to pour out somewhere. And then that shows how the caves are connected. Another neat thing about Mammoth Cave is that there are animals that live in the cave, and these animals have lived and evolved in complete darkness to the point where they're not blind, but they literally have no eyes. This fish right here, this crayfish, is very similar to the little Herbert crayfish that we have as a class pet, but they have no eyes. They're not blind. They're completely eyeless because in a cave, there's no light unless people hook up lights like this, and therefore they don't need it. But they have these really delicate senses that allow them to sense the things around them so they can survive in that dark environment. Okay, our next national park that's a little closer to home, it's about the same distance from Mammoth Cave, is the Indiana Dunes. Here's a picture of the Indiana Dunes. It looks just like a beach by the ocean, but it's by a lake, and it's in Indiana. So instead of driving south, if we were to start in Amelia, where you guys are now, and not too far from where I'm at, and drive about northwest, we would get to the Indiana Dunes in about pretty much 5 hours. So we're in the car a little bit longer to drive to the Indiana Dunes. The Indiana Dunes are beautiful. You feel like you're at the beach when you're there. They're very sandy, different types of grains of sand, and you're right by the lake. So the Indiana Dunes were made when massive amounts of sand were deposited about 14,000 years ago. So something came through and dumped all this sand here, deposited about 14,000 years ago. And what that was, and we're going to talk about this a lot later on in science, is this massive sheet of ice that came from north of here. So it came from Canada, made its way down about this far, and then stopped. So when this ice started melting, this glacier, it deposited all this sand. And today, wind and water weathering and erosion continue to make changes. So these dunes are changing because of the wind. It can be very windy there. The waves of the lake are causing weathering and erosion to this day. And here's another shot of it from down one of the sand dunes. Here we're at the top of one of the sand dunes. Here we're towards the bottom at Lake Michigan. So here's another shot, and here is another shot. So if you are at the Indiana Dunes, you can actually look across Lake Michigan and see the city of Chicago. So this is the city of Chicago with its skyscrapers across the lake there. Here is the Indiana Dunes at winter, and the lake is frozen. You can see there that does happen sometimes. And this part is really neat. So one of the things that's really important for the Indiana Dunes are the plants that grow there. These plants are holding the dunes together. Now think for a moment, what do you think, or how do you think these plants are holding the dunes together? These plants have really long root systems, and these roots are holding the dunes together. If these plants are gone, the dunes would eventually weather away. They would leave. They would be washed away by the water or blown away by the wind. So you can see in this picture right here, the areas where the plants are growing are holding the dunes together. Where there are no plants, the dune has been weathered away. So these plants are really, really important, not just in Indiana dunes, but wherever we see sand dunes, like at the beach, for example. All right. Next national park and next amazing feature is Niagara Falls. So here is a picture if we were in a plane looking straight down at Niagara Falls, and this is really neat. Check this out. So over on this side is the United States, New York State, right? Here we would be in the United States. If we went across this right here, we're in Canada. So that's how close we are to Canada, and we're being separated by Niagara Falls in this place. So from here, United States, here, Canada, which is going to be really important because this area is important when we talk about social studies stuff, when we talk about War of 1812, but that will come later. All right, Niagara Falls is a little further away. It's about 7 hours in the car. So if we're driving, we're going to be driving all the way through Ohio up into a little part of Pennsylvania, New York State, right here. And that's why I was saying, look, United States, Canada, right across the border right there. Niagara Falls, we have Lake Ontario that goes down into Lake Erie and dumps out that way. Niagara Falls continues to change from physical weathering and erosion, and it's water. This is all water. This massive amounts of water that's dumping over the falls every second, every day. And these are some different shots. Here are the main falls. These are what we call the Horseshoe Falls of Niagara Falls. This is another set of waterfalls in the Niagara Falls area. So these two waterfalls are different, and they are very close to each other. So this waterfall right here is just on the other side, like it would be right over here. So these two massive waterfalls are right next to each other. The same forces that created the Indiana Dunes created Niagara Falls. So the glacier that created the dunes I just talked about created these waterfalls. Here's the Horseshoe Falls again, and check this out. 681,750 gallons per second go over these waterfalls. So almost 700,000 gallons per second, right? Go over that waterfall, and it's just incredible amounts of water. So here's some neat background on Niagara Falls. So this is one of the waterfalls I just mentioned here. And this guy right here, his name was Nikola Tesla, and just a pure genius when it comes to electricity and its uses. He read about Niagara Falls as a boy before his family came to the United States. And as a boy, he was reading about Niagara Falls, and he had the idea of if there's any way of making electricity from the movement of water, because he was familiar with the discovery of Michael Faraday, who noticed the magnet in the copper coil moving. You could move the compass needle. We talked about that in class. So what happened? Idea as a boy, and then reality as a man. He ends up building, with the help of many other people, a power plant. This is the first power plant in the world that used the flow of water to create electricity. And here's just an idea of this. So we have this water that's pushed through this tube, spins a fan blade, spins the generator, creates the electricity. If you remember those hand cranks that we used in science class, the little white thing that had the handle and you cranked it really hard and some of you blew out a light bulb, that's how that works. And if you were to visit Niagara Falls today, they have a statue of Tesla looking at the waterfall that inspired this idea. And cities all over the world generate their electricity this way. It's good, clean energy, and it came from his thinking from when he was a boy reading about the falls in a book. All right, a little further away from Amelia is the Badlands, and this is an amazing place. The Badlands, if we were to get in the car here in Amelia and drive out west, we would be in the car for about 17 hours. That would be a long car trip, but it would be worth it because the Badlands are super cool. They are in South Dakota. And what we would see if we went to the Badlands, we would see something like this. So the Badlands were formed when an ancient volcano erupted and deposited, right? So we're using deposition, thousands of tons of ash in this area. So this area was completely covered in ash. There's ancient floods and everything else, but the main formation of this was ash being dumped in this area. Here's another shot. And this is going to be interesting because what I want you to think about is today, physical weathering and erosion from water when it rains makes these amazing formations. So I like this picture here because you can see these little flat spots of grass. And as it rains, that rain is going to wash away some of that soil and expose that old volcanic ash. So at one point, this was flat, grassy land, and then just over millions of years, with rain and weather and everything else that's going on, this ash layer was exposed. And here we have these really neat shots of these rocks that don't weather away being left on top of the sand that is being weathered away. So these rocks have been up here for a while, and at some point they're going to fall. We're going to see something like this similar from another park in just a moment. So here's another neat shot of those formations. You can see the layers of sediment, kind of like your sediment bottles that we made. Here's what it would look like if you were walking around through the Badlands. Here's another neat thing. The Badlands, I mentioned this in class, I think, or you can find all sorts of fossils in the Badlands, and they have signs everywhere telling you that it is illegal for you to collect fossils in the Badlands. That's a protected area, it being a national park. And the Badlands are a great place to find these amazing fossils of extinct Ice Age mammals, like this animal, for example. This was a deer type animal that had saber-tooth style fangs, antlers on the back of its head, and this weird set of antlers in the front. It's amazing. Here we have this other animal that we have evidence of that lived in North America, and this is what it would look like if I were standing next to it. So imagine a meat-eating pig that was taller than me that ran on hooves. This was a real animal. We have bones of it from this area. We also find things like this giant rhinoceros-style animal, much bigger than the rhinos that we have today, that didn't have one horn but had two of them. And then we have something that looks a little more familiar. See if you can think about what that is. If you guessed it was a saber-toothed cat, you were right. Right. So we have evidence that saber-toothed cats lived in North America because we find their bones. But that's a whole other fossil thing. We'll talk about that later. So Badlands are a great place for finding fossils. So that's a neat feature of that park. So this is another park in the United States. This is Arches National Park, and this place is absolutely beautiful as well. They all are, but I'm going to say it for each one. So Arches National Park, if we hopped in the car, it would take us one entire day if we just kept driving and did not stop. So here we are in Amelia. If we drove straight west pretty much through Indiana, through Illinois, Missouri, Kansas, Colorado, up the mountains, down the mountains, we would be in Arches National Park in Utah. So Arches National Park, the main thing about Arches National Park is that it's almost all sandstone. So here's an example sandstone. You can see these really neat layers in it. So imagine your sediment bottles if we left them for several million years and never moved them. This is what would happen. But this sand came from an ancient sea during the time of the dinosaurs. So if we could time travel back in time and see the Utah area during the time of the dinosaurs, we would be standing at the edge of a beach, of a shallow sea that ran right through the United States, or North America, I should say, during the time of the dinosaurs. And that sand cemented in and made sandstone. So we will see at Arches National Park, it gets its name because there's all these beautiful sandstone arches. And some of them are really thin, like this one. Some of them are really fragile, like this one. This is the most famous one. And some of them are a little bit thicker. So if you had to think about it, this arch here is a little bit older than this arch, because eventually what's going to happen is, because of weathering and erosion, these arches are going to get thinner and thinner and thinner until they collapse and they're no longer an arch. So this is physical weathering and erosion from the wind. So if you remember back to our stations, this was a station where you were blowing through the straws and causing that wind erosion in that tub, right? If you had the goggles on. So this is an idea, right? So this is what we see. The wind is going to blow the really fine pieces of sand higher. The bigger pieces are going to go across the bottom. Think about what you saw in the tub. And what's going on is that these bit larger rocks are just being sanded down by the wind over millions of years. And this rock right here, and this is a similarity. You can see the people down here, right? So when that goes away, you'll see the size of this boulder. Eventually, these things are going to fall because wind erosion and weathering is going to break that apart, and then gravity is going to bring that down. At one point, this would have been an arch as well, but it just broke to pieces. So this is all created by the wind blowing those particles of sand and weathering them down in these neat ways. Here's another neat thing about Arches National Park. So if you were to go there, you would see this log cabin. And this log cabin was built after the Civil War. So this cabin was built after the year 1863. And this cabin is still there. And it's still the original cabin because it's so dry out there. It does get some rain and snow, but the weather preserved this cabin. And here's what's really neat about it. This was built by a guy whose last name was Wolf. And this gentleman was from Ohio. And he moved all the way to Utah because he was wounded in the Civil War. And he thought the dry weather would help his injury. So he moved out there, lived with his family in this amazing area. Now, it wasn't a national park back then. It was just the desert. But he was living out there, and you can see his cabin. You can also see these amazing petroglyphs. We call these are images that are carved into stone. And these images were carved by Native Americans who lived out in this area thousands of years ago. So we talked about all of our Native American peoples who lived in Ohio, the Adena, the Hopewell, the Fort Ancient people. Well, there were people living out in the desert in this area during that time period as well. And these are images that they carved into the rust. That color right there, it's rust, just like your nail in class. And these images are thousands of years old, and it shows their way of life through their pictures. It's absolutely amazing. All right, Yellowstone National Park. Yellowstone is our first national park, and this is a real picture of a real thing in Yellowstone National Park. There is this walkway right here, and this is full of people, and you can see how big this thing is. So Yellowstone National Park was our first one. People realized back then we needed to protect this area, and it's absolutely amazing. So Yellowstone is a little bit closer than Arches, 16 hours and 59 minutes, so pretty much just 17 hours, a little bit closer than Arches. But here we go. So Yellowstone gets its name from the Yellowstone. You can see it right here. That is seen by the Yellowstone River. So the Yellowstone River cuts through. We have this waterfall. It's weathering away the rock. It's eroding it away and depositing in other places. So this yellowish color of the stone is where we get the name of the park. Yellowstone is home to all these amazing features. These are hot pools of water, and just, yeah, there's many things to look at it. I'm just having a hard time organizing my thoughts. All right, so here's the main thing about Yellowstone. Everything in Yellowstone is driven and shaped by volcanic forces. This is a cross-section of what's going on underneath of Yellowstone. Yellowstone sits inside of what is called a caldera. Millions of years ago, there used to be a volcano, above ground volcano that destroyed itself. And a caldera, what happens is if you take your hands and make it into like a cone shaped, and then if you turn it downwards and make it into a bowl shape, that's what a caldera is. So millions of years ago, Yellowstone used to be a volcano the way we think of it. It completely destroyed itself, but the magma is still underground and it's heating everything. So this is, if we could cut Yellowstone in half, this is what we would see. There is hot magma very close to the surface of Yellowstone. So this causes almost everything in Yellowstone that we're going to see. So for example, we have these geysers, these massive jets of hot steam and water shooting up into the air. That's being caused by that magma underneath the surface. We have some animals here, and what's neat about it is these animals are going to hang out around these hot volcanic features during the winter. So the animals are using this geology here to survive. It's really cold there in the wintertime. So these animals are warming themselves in these areas. It's really neat to see that. We also have these hot springs. So we have this pool of water that can go down hundreds of feet, maybe even thousands of feet deep. And this yellowish green color, that's bacteria that's living in this hot, boiling acid water that would kill everything else but it. So this bacteria is just loving this hot pool of water right here. Anything else, we would die in this water. People die in this water every year at Yellowstone. I'm going to talk about that in a moment because they don't think it's going to hurt them, but they don't understand the geology and they don't pay attention to the signs, and it happens. The bacteria, though, great. Everything else, not so much. They also have these pools of this gooey mud that bubbles. They're called mud pots. So if you imagine if you had a straw that you stuck down into a really thick milkshake and blew out bubbles, that's what this thing, but instead of a milkshake, is this boiling hot mud that's being heated by magma underneath of the ground. Here's another shot here. You can see this is that giant pool of water. It's called the Grand Prismatic. You can see the walkway through here. And I want you to notice there's nothing living in this area because the only thing that lives in that type of water is bacteria. So as this thing spreads with its geology, it's going to kill off these trees. And yeah, like I said, nothing can live in those conditions. Here's another shot here. And if you were standing there, you would feel the heat. You would maybe even smell like a rotting egg smell, kind of like when fireworks go off. That's the sulfur. Yellowstone has lots of geysers. Here's another shot. This is Old Faithful. Here's another geyser. And this is how geysers work. So they're pretty much like teapots. So if you imagine a chamber here, it's showing how this groundwater sinks in. It fills up these underground chambers, and the heat is heating up that water into the chamber until it escapes out the opening. So imagine a teapot on your stove. This is exactly what it is. Those hot springs, similar idea, but they just don't have a channel that's going to force it out that way. They don't have those chambers. So you can just see it's water seeping up and filling up a chamber, an opening like a pool right here. And in this case here, they have a chamber for steam to fill up, and that escapes. That gas wants to escape. Here's another shot here of the walkway. These walkways are really important at Yellowstone, and here's why. They have these warning signs all over the place of this poor little child who did not read the warning sign, and now his feet are melting off. And here's another child looking on in horror. And I really hope that person's not their dad who's just ignoring what's going on. But this happens. This happens. The crust in this area is unpredictable. And they're telling you over and over again, unstable ground, it's boiling water, stay on the trails, don't leave the trails. Because if you do, you may burn your feet off like this poor child who is regretting his choice to leave the sidewalk. So you don't want to do that. But unfortunately, people don't listen, and it happens. Every year people die in Yellowstone because they're like, I don't need to stay on the sidewalk, and they leave it. Bad idea for them. It's thin crust just below the surface. You wouldn't run into magma, but you could run into boiling hot mud or boiling hot acid water that is being fueled by that magma. All right. It's a great poster. Great. Look how sad he is. All right, here we go. Our last one we're going to talk about is the Grand Canyon. And the Grand Canyon here is a great example of weathering and erosion. This thing is massive, massive. If we were to go to the Grand Canyon, we would need to be in the car for about 2,000 miles. We're talking about 30 hours in the car, all the way out here in Arizona. So that's a long trip. Worth it, though. Totally worth it. The Grand Canyon is the largest canyon in the world with an average depth of about 1,600 feet. So on average, there's some parts of the canyon that are deeper than others, but on average, it's about 2,000 feet deep. Here's the other part too that's amazing. The volume, how much it would fill. So if you and I wanted to fill in the Grand Canyon, we would need 4.17 trillion cubic meters of soil. So if you took soil and made it into a cube that was a meter high, a meter long, and a meter wide, we would need about 4.17 trillion of those cubes. This thing is so large that we can see it from space. This is a satellite image of the Grand Canyon from space. That's how big this is. All the other national parks, you can't see them from space. Mammoth Cave, mainly because it's underground. But this is massive. So physical weathering and erosion from the Colorado River is what formed this canyon. Here's the Colorado River right now. This is just one bend of the Grand Canyon. And it's still shaping the canyon, but that is the main force for that Colorado River that's going through. This is just another shot. And here's some people on an outlook. So it is, you cannot stand in one place and see all of it. It just stretches on for as long as you can see. And what's amazing about the Grand Canyon is that it has a record of almost the entire history of the Earth. You could start at the top of the canyon. If I stood up here, you're going to find newer rocks, newer fossils, and you can work your way down. And you can, depending where you go in the canyon, you will be able to find fossils from every age of the Earth, from newer animals, dinosaurs, and all the way down to the bottom, simple animals. It's really, really amazing, and it's shaped by the flow of that river. All right, so at the bottom of your notes where you've been writing things down, you will notice I gave you some websites for live cams. Yellowstone and Grand Canyon, they have cameras that are set up and they are streaming live. So if you go to those sites, you will be able to see what part of Yellowstone National Park looks like right this very moment. And this is a screenshot from when I made this presentation. So this is what was going on in Yellowstone in that area right that moment. You can see all the snow that they have out there. Hope you enjoyed this. We'll do another one about amazing places in Ohio. If you need to go back and watch any of this, that's great. You can do that. Make sure you send in your notes for me so I can see what you wrote down and that you are following along with me. All right. Thank you guys. Have a great day. Bye.